Hi guys, and welcome to another video. In today's video lesson, we're going to be looking at grade 10 mathematics, and we're going to be looking at squaring of a binomial and multiplication of a binomial times a trinomial. So let's get straight into it. If I look at the work schedule and if I just go through it very quickly, you'll be able to see that I am now at point number 4, which is multiplication of a binomial times a trinomial. And this is under algebraic expressions. Now, let's go look at recent past examination type questions. So if we look at this, we will look at the November 2018 paper first. And as you can see, we've got the November 2018 paper in front of us. This is the first question. And question 1.2.1, this is a binomial here, 2 terms times 3 terms, which is a trinomial. Let's go further down and we can see here that we've got a binomial all squared. So therefore we need to square this binomial in order to solve this particular problem. So let's look at 1.2.1 first, and then we'll look at question 1.3. So let's say it says simplify the following expression fully. So let's just get that so that we can answer this particular question. Okay, so it says simplify the following expressions fully. So this, remember, is a binomial, which is x plus 2, and we have a trinomial, which is x squared minus x plus 3. So therefore, we want to now use the distributive law here. And we want to take x into the brackets like so. So it's going to be x times x squared, x times minus x, and x times plus 3. So we're going to take the first term, which is positive x, and multiply it by every other term in the second bracket. X times x squared is x cubed. Now that comes from our knowledge of exponents. Remember, if you've got x to the m times x to the n, it's equal to x to the m plus n. So therefore, remember, the invisible one is here. 1 plus 2 is equal to 3. Remember, common bases, and you are multiplying, so you must add the indices. All right, x times minus x is minus x squared. Once again, guys, remember the invisible one there, right? X to the 1 times x to the 1 is equal to x to the 1 plus 1, which is x squared. Okay, so that's how you get, and obviously you need to know your multiplication of your signs. A positive times a negative is a negative, and so on and so forth. So let's continue now. X times plus 3 is plus 3x. And there we go. So we took the first term and we multiplied every other term. Let's double check. X times x squared is x cubed. X times minus x is minus x squared. X times plus 3 is plus 3x. Now let's do the same thing with this positive 2. Using the distributive law, we're going to take positive 2 and multiply it by every other term in the bracket. So we're going to get plus 2 times x squared, that's plus 2x squared, plus 2 times minus x, minus 2x, and plus 2 times plus 3 is plus 6. Now, what do you notice? We've got 1, 2, 3, 4, 5, 6 terms now, right? Remember, you've got 2 terms here, a binomial, times 3 terms, trinomial, and you must end up with 6 terms. Once again, remember, terms are separated by plus or minus signs and joined together by multiplication and division. If we simplify now, remember that we can only add like terms. So this x cubed is going to come down here, and this positive 6 also is going to come down here like so. The like terms means that terms must be identical in terms of their variable part. They must have the same letter and the same index. So which are the like terms? Let's group them. X squared and minus x squared here, and positive 2x squared are like terms. Why are they like terms? The reason is that you can see this letter part must be identical. Therefore, we can now add them up. So you now only need to worry about the coefficients. Like for example, negative 1 and positive 2 is going to give you positive 1. So therefore, that's going to be positive 1. So you can write positive x squared. Remember, the plus 1 is there, right? The coefficient of x squared. So simplifying minus x squared once again and positive 2x squared will give you positive 1x squared. Which else are like terms here? Which other terms are like terms? Plus 3x and minus 2x. So that's like now saying 3 apples minus 2 apples is 1 apple. Okay, excuse the analogy. So positive 3 minus 2 is going to give us positive 1. So therefore we're going to write there plus x. So 3x minus 2x is plus x. So therefore we have x cubed plus x squared plus x plus 6. And all these terms now are unlike terms. So once again, learners, when we multiply a binomial, which is 2 terms, there's 2 terms there, times a trinomial, 3 terms there, we're going to use the distributive law, which means to multiply the first term in the first bracket by every other term in the second bracket. And then we're going to take the second term in the first bracket and multiply every other term or every term in the second bracket. Remember, 2 terms times 3 terms will give us 6 terms. Also note that we can only add or subtract like terms in mathematics. So what are like terms? Once again, like terms are expressions which or whose letter part or literal part is identical. So you see plus 3x and minus 2x are identical terms. Okay, they are the same terms, so we can simplify them. Now let's look at the next question that we said we're going to do. So we're now going to be looking at squaring of a binomial. Right, so this is 1.3 in the November 2018 paper. So let's see, what do they want us to do here? So for this particular question, it says determine the value of 3p plus q all squared if 9p squared plus q squared equals to 12 and pq is equal to minus 3. So they want the value of this expression. So what we're going to be doing here is we're going to be squaring this particular binomial. Remember, a binomial is 2 terms and there's it here, it's squared, right? There's 2 ways in which we can square a binomial. So let's look at the both ways that we're going to do it, right? So the first way is to expand, and then we're going to use the FOIL method, which is first, outer, inner, last, which is to multiply a binomial times a binomial. So let's look at that method first. So we're going to say 3p plus q all squared, and that's going to equals to 3p plus q times 3p plus q. So we've expanded, so that's done. Now let's use the FOIL method, which is the multiply the first, then the outer, then the inner, then the last. Now this is very similar to what we did in the previous example here. It's going to take the first term and we're going to multiply every other term, like so, using the distributive law. 3p times 3p is 9p squared. 3p times plus q is plus 3pq. Then take the second term and multiply every other term. Plus q times 3p is plus 3pq, and plus q times plus q is plus q squared. So what does this leave us with? So we go back to the question. It says here that 9p squared plus q squared is equal to 12. So let's group that. 9p squared plus q squared, 9p squared plus q squared, and then we're left with plus 3pq, and plus 3pq is, remember those are like terms. Now why are they like terms? Because you got pq and pq, the letter part is the same. So it's going to say 3 apples plus 3 apples is 6 apples, so that's going to be plus 6pq. Now let's substitute here. So 9p squared plus q squared is equal to 12. We're going to write that down there. 12 plus 6 times, what's pq? Pq is negative 3. So we're going to write down negative 3 there. 6 times negative 3 equals to 12 plus 6 times minus 3 is minus 18. And 12 minus 18 is minus 6. Once again, learners, remember that we can use the following method to square a binomial, which is to expand and use the FOIL method. The other method that we can use is to use the rule. So number 2, we can use the rule. What is the rule? Rule is, so step number 1 would be to square the first term. So we'll just square the first term. Step number 2, we will just double the product of the two terms. So we'll double the product of the two terms. And then step number 3 is we'll square the last term, square the second term. Square the last term. Right? So square the first term, double the product, and square the last term. Okay? And this will be applying the rule. So let's look at it. So it will be 3p plus q all squared equals 2. So if you square the first term now, remember 3p all squared is equal to 9p squared. So therefore you get 9p squared. Double the product of the two terms. Step number 2, double the product. Product means to multiply the two terms and then double it. So it will be 3p times q times 2. And that will equals to 3p times q is plus 3pq plus 3pq times 2 is positive 6pq. So it will be plus 6pq. And let's write it properly, pq. And square the last term now will be plus q all squared. Now remember, when you square something, the result is always positive. So the signs don't matter for the first and the third step. However, remember that signs matter for the second step. That's very important. So make sure you understand that. So here we'll have positive q squared. So that will be plus q squared. Now if you compare the two that we have here now, 9p squared plus 6pq plus 6pq plus q squared and plus q squared, you're going to get the exact same answer. And thereafter now you're going to do the same thing that you did there, which is just to substitute and solve, and we'll end up with the same answer, which is negative 6. Learners, if you have not subscribed already, subscribe to JL Maths. You can also check out my Facebook page, Justin Lazarus Mathematics. You can watch all videos in order of the work schedule on jlmaths.com. And I'll catch you in the next video.